Hello everyone, in this video we're going to talk about covalent bonding. Now in covalent bonding, it's basically the idea of this type of bond is sharing electron between each other. It means that both sides, both elements, they don't want to lose their electrons. Imagine this one, you have money, but it's a lot of, it's a somehow let's say that it's not a small amount of money, you're just willing to give it up, and then you want to, let's make it somehow funny, you're trying to, what do you call it, have a restaurant. You have money, but it's not enough, and there's another guy has money, but it's not enough. So what you two guys do together, both of you can have the money to buy that restaurant. So you're gonna share the money together, you will be partner, and you're gonna buy that restaurant, and that restaurant is bonding you, those both of you together. That's basically the sharing point with you. Each of you may have different things, but the only connection that you have between you guys is the restaurant. Why? Because both of you put some money together to buy that restaurant. Imagine that one is your friend. You're not willing to give that much money, half of the money to him, yes? And he's not going to give it to you, or she's not going to give it to you just like this. So it will basically go for sharing. This we call covalent bonding. Between those elements, they have sometimes 3, 4, they need 4 electrons to be filled, and they have 4. They're not going to will to give up those 4, and there is no way that anyone to give them 4 electron. Say there's gonna go and have a covalent bond with 4 other electrons. Maybe you can be partner with 3 more, not just one person. With 3 more, basically you're just sharing with them some money, and you will be partner with all of them. This is how the covalent bonding works, and we call them directional. Why directional? Because it is somehow just for that part you sharing it. So this is how does it work. How does this one work? Let's just look at the picture. We have it here. H2O, it's one of the things that it's a covalent bonding. We have it here, a covalent bonding that we have it here. Oxygen basically has 6 valence electron. He has it here. It's not willing to give those 6. You want to take 2. It's gonna bond. There are sometimes oxygen goes for the other ones. Yes, some of them they just giving the 2 electron to oxygen. It can be possible, but here with hydrogen has 1. Is gonna come and combine with this one. Look, this is where the direction is started. Means that why? Because all the bond is concentrated at this point here. The bond basically concentrated at this point here, and the other hydrogen comes is bonded with this one. Now both sides are satisfied. The oxygen has 8 electron in the outermost shell, stable, and hydrogen has 2 stable. Both sides happy. But the bonding they have it here is this is a sharing between them. So this is still for oxygen, and it's for hydrogen. This one is for hydrogen, for oxygen. Both of them they're using the electron between them. That's why we call them sharing electrons. We have some other examples, because we call them directional, because in the direction of the bond, it changes the direction of the bond. We have it here. This is covalent bonding with carbon. Now carbon has 4 valence electron and is willing to have 4 bonds. So each carbon basically, this is the dot that we used to use them, 4 dot, and is willing to create 4 bonds with the other person. Not gonna willing to give those elements or those electrons, and some people that trying to share it with carbon. So carbon and hydrogen would do it. There's a lot of polymer. Basically we have those covalent bonding in polymers, that's what make them what. And one of the famous polymer that we have is polyethylene. The water bottle that you see them is polyethylenes. It's basically carbon and hydrogen, and it condensed, or the highly dense polyethylene that we used for water bottles. Those are covalent bond. We have them there. So the bonding basically it's sharing electron between each other. Now we're not going to be positively negatively charged here. There will not be positive negatives that we will, because they're just sharing between covalent bonds. So this is something that, I mean, sometimes the gases, I mean, chlorine has been just simply join with another chlorine. I mean, one they sharing to each other, and they're gonna basically have one bond between them. I mean, none of them is willing to give electron to the other one, and both of them they need one electron, and they're going to share with each other one bond to fill each other. With the dots, basically, they used to do it, and the two dots come over each other. Both sides will be happy by sharing the electron between them. This is for carbon, for example, two bonds with carbon each other. One of them, for example, take this carbon, two here, and all the to do it. And this is polyethylene, basically, polyethylene molecules, which is the plastic, the water bottle, we have them. So basically the carbon and hydrogen backbone, the carbon backbone with each carbon having two hydrogen, this is there. In a diamond, basically each carbon is supposed to have again 4 bond with the carbon. For example, taking this one, will be having 4 bonds with the other ways. Now, not only the bond is basically making the element or the strong, no, the location of those, I mean the arrangement of those atoms, basically the carbon atoms, that's gonna change the properties. That will be the second, the chapter 3, we call them crystal structure. I mean, you realize, for example, this carbon has 4. I mean, graphite basically has similar, but why the arrangement, basically it's making it, this crystal structure is making some more property for the material we have it there. I mean, those are some of the covalent bonding we have it there. We're not going to go for looking for the potential energy, the way that those atoms are they close to each other, those two are attracting each other or not. For example, they have a way that to do it, which is not our interest here. Well, let's do metallic bonding in this video as well. Now, metallic bonding here, what will happen in metallic bonding? I mean, the name it is metallic bonding. It's mainly in the metals. Mainly in the metals, they have this type of bonding. What kind of bonding is this? It's neither sharing. I mean, it's not you simply giving one and someone is taking one. It's not like this, and it's not sharing. It's what each of the let's say that you have a charity, and there's people within those charity organization. Each of them basically put money. They put money within there, and all of them they're gonna use from that money. Imagine it like this. This is they called an electron C. Each of those elements, they will give up some electrons. They will just take it out from their pocket and leave it in an area. They're not gonna give it to someone. So they call it electron C. For example, iron, or for example we have a metallic type in copper, for example aluminum, gold. Those are what they do. I mean, this is metal alone, yes. So how is it stable there? How is this stable? For example, how copper is stable? I mean, it has some valence electron. So what will happen to those valence electron? They're going to give it up. I mean, they give it up. I mean, they will just put it around themselves. So each of those copper elements, they will give up their electrons, and all electrons will be around itself. Each of them, they can get benefit from those electrons. They call them electron C. And how does it look like in a better way to check them? This one. And a better way to check them, it will be something like this. They call them free electrons. I mean, metallic bonding, ions surrounded by free electrons. So each of them, they give up electrons, and they will call them an electron C. There will be a lot of electrons around those electrons around them. They will be positively charged. And the electrons are negatively charged. So they will be surrounding or around those atoms of, for example, iron. We have it here. So we call this one metallic bonding. Now, metallic bonding has some features for us, some properties. Now, this is say that the bond does not break. This is one of the important characteristics that is going to give us for those metals. Now, metals, when in chapter 6 and chapter 8 we're talking about metals, mainly metals, when we apply force to them, the bond are not simply breaking. What will happen? They will slip, and there will be some arrangement. Yeah, the shape is going to change, but the bond will regenerate it. Why? Because the electron C's that we have them is simply just not letting the bond, there's no specific bond to be break, so that's why they will call them some plastic deformation. I'm not going to explain what does plastic deformation here, but in chapter 6 we discussed this one in detail. Plastic deformation, what does it mean? I mean, how metals, and this is the information is going to give us that if there is a metallic bonding we have it there, we know that this material is ductiles. We call them ductile materials. Ductile materials. So this is going to give us an information that we know that how those metal behaves under load. Well, not all the metals, we call them transition metal. Now the name of transition metal we explained here. It's not purely metallic bond. Some they have mixed bond, that will be between covalent bondings. I mean, more brittle than, like they will be a little more brittle. I mean, rather than, because if it is pure metallic, they will be ductile, but when we have the other bondings between them, especially with covalent bringing there will be a bit brittleness come into the elements properties, which we call them transition metals. Now we say that why iron is brittle. Yeah, iron is something, it's not ductile, I mean somehow brittle shapes we have it there. Well, we're gonna create another video for the secondary bonding. Thanks for listening.